Okay, here we are on the last step, step 9. I hope you've enjoyed the process and get a sense of how this works, as well as learn something about probability and about Excel. All right, so we're going to finish up on 2 conditional probabilities. Let me go ahead and no-fill these guys so you can see what I'm doing a little bit better. The first one, what we're going to ask is, what's the probability of a driver being impaired during the accident, given that they're female and a good student? So what we need to do is find out the number of impaired drivers that are also female and also good students. So to do this, we're going to use an array function again. So we're going to go equals sum. And because we need to compare 2 things before we do our counting or our summing, that's one of the reasons that we're using an array function. So, and I also want to say we don't want to use count. So we want to actually sum these guys up. Because there may be, if you use count, then what you're going to end up with is the number of female good students. And we're not actually going to see what happens with impaired. If we sum those up, because it's 1 for impaired and 0 for not, the sum of them is just the number of impaired drivers. So that's the logic behind what we're doing on this one. So we're going to do an if, and we're going to go to our account data. And we're interested in the male-female relationship. And then we want to say it is in fact equal to 0. So that means it's female in our database. And then the next thing is if, and we want to take a look at good student at this point. So we'll click on our first good student, Control Shift down, and then we're going to say if that is in fact equal to 1. And now we're going to do the sum, and we can kind of pick any, well, we actually want to pick the column E, which is the impaired driver. It's kind of in the way. I'm just going to click down 1. Control Shift and down to get it. Now we end it with our parentheses, and there should be 3, and then our Control Shift enter. So there's a total of 111 female good student drivers that actually had an accident where they were impaired. So then our proportion is just going to be equal to the number of events divided by, and we'll come to our descriptive statistics tab, and we're interested in impaired, so then I'm going to use our sum down here. Alright, so that becomes our probability. And then we'll just throw some arbitrary numbers in here for 3, 5, 6, doesn't matter. And 10, we just need this to get our probabilities set up. And then we're just going to do our standard binomial distribution at this point. So equals bino, and this is going to be at most, so we'll just click here, comma, and then we need the number of trials, and we'll hit F4 to lock that one in, comma, and then we want our probability, which is here. We'll hit F4 to lock that one in. And then finally, we want it to be cumulative in this value. Now I'm just going to drag this down 3 spots. And we're just going to make our adjustments. So this is at most, cumulative. So it's basically saying there's a 100% probability of at most being 4 drivers. Now our at least, we want to go 1 minus the binomial. We need to subtract 1 from our events. and the rest of it stays the same. So it says that there's an extremely low probability of having at least 3. And finally, we're going to do our exact. So when we're doing our exact, we're just going to change this guy to 0. Now we don't want a cumulative distribution. So there's almost 0 probability of having exactly 6 female, good student, impaired drivers out of 10 trials. Okay? So this is a conditional probability, and then we can use these conditional probabilities to go and calculate what the expected costs are per accident, etc., etc. Now, one of the things I want to stress at this point is that this obviously is pretty low probability, but what we don't have in the database is whether this person has been in an accident before. So if we have an actual female that is a good student that had an impaired accident, it's going to change the probability of them having another impaired accident. All right, so we're not looking at some of these farther on conditional probabilities, but that's exactly what actuaries would do to try and get an estimate of what the costs are going to be per accident, and then be able to accurately price the insurance, as well as make sure that they have reserves on hand to pay out what needs to be paid out. So our second conditional probability, again, just blank these guys out. We want good. What's the probability of a good student given that they're male and under 25? So a little bit more challenging from an equation standpoint, but not terribly challenging. Again, we're going to do our sum if, and now our if statement. So the first question is, are they male or not male? So we want a male. Come over here to our data. We'll go ahead and select male, or the male-female column. Control Shift down, and then we want that equal to 1. And then our next if statement is going to be dealing with age. So we want to know if they're under 25. So we'll go ahead and select our age group. And then we want to say that it's less than 25. And then if that's the case, we want to go ahead and look at the sum of them being good students. So we're going to zip back up here to the top. We'll pick our good students, go down for the group, 3 parentheses to end it, and then a Control Shift Enter to get our valuation. Oh, because I got a decimal point here instead of a comma. And again, now we have to do a Control Shift Enter again to get our value. And then the calculator proportion, this is simply going to be equal to, and we'll come back to our descriptive statistics tab. We're interested in good students, so we want the sum of good students. And actually we want to take our and divide it by the sum of our observations. So there's, if you're male and you're under 25, there's a 2% probability or proportion that are actually also good students. So we're just going to do our at most, at least 3, 4, 5, and we'll just make it out of 10 trials again. So then our probability is our Bino distribution, and our number of trials, number of successes, our number of trials F4, our probability F4, and then we want a 1 for cumulative. And just like we did before, you'll just drag this guy down and go ahead and finish out the equation set. So that ends the project. A little bigger than I thought it was at the beginning. Took a little bit more time, but you can see that there's not very many variables, right? We have grand total of 5 variables, 1, 2, 3, 4, 5, I guess 6. And we really haven't even penetrated all the different conditional expectations and binomial distribution things that we could have done in this process. So hopefully, again, you're learning some Excel functionality, a little bit about actuarial science in terms of its what they do. This would be a casualty application as opposed to a life insurance application, and then how to set up spreadsheets, how to get plots put out, how to do tables, and then letting Excel do the work for you so that you can just enter a few variables and then have all the probabilities and valuations taken care of. All right, so I'm going to go ahead and end it here. I hope you enjoyed the project, and thank you very much. Bye.